There we go. Thank you, everybody, for the March 2024 installation of the Microsoft Data Platform Continuity Virtual Group. With me today is an absolutely amazing gentleman named Andrew Pruski. He is going to be talking about SQL Server and Kubernetes, just one of those really fun topics that, from my background being infrastructure, when you're dragging along an operating system with a bunch of different deployments and things, it's a lot to drag along. Containers, let's just drag along the app, not the OS. So with that, I'm going to turn it over to you.
Thank you very much. And let me share my screen here. There we go. Can everyone see my screen? All good?
Yeah.
Great. Welcome everyone to this session, SQL Server and Kubernetes. Just a little quick bit about myself first. My name is Andrew Pruski. I am a field solutions architect at a company called Pure Storage. But before that, I was a SQL Server DBA for my sins for around 15 years. I'm a Microsoft Data Platform MVP, Docker Captain, VMware vExpert, basically a SQL Server nerd. I'm originally from Swansea in Wales, but have been living in Dublin, Ireland for the last 10 years now. So it explains why my accent's a little bit here, there, and everywhere. My contact details are on the slide there, at DBA from the cold on Twitter and dbafromthecold@gmail.com. So if you have any questions after today, please feel free to reach out. I'm always willing to talk about this stuff. My blog's there as well, dbafromthecold.com. Posted multiple articles about running SQL Server in containers and in Kubernetes, some of which I'm using to base this session on, and some of which go into even further information. So if you want to check that out, you're more than welcome. And then finally, there's my GitHub account. All the slides and the code for the demos that we'll be doing today are on my GitHub, and I will post a link to that exact repo at the end. So on to the session. What are we doing today? Well, what we're going to do is we're going to talk about the little bits and bobs of Kubernetes. We're going to talk about control plane components. We're going to talk about worker node components, and then how to deploy our applications to give you the background knowledge and the code to be able to get started with deploying SQL Server to Kubernetes. So first things first, let's talk about what Kubernetes is. The definition there is from the kubernetes.io website, and it's basically saying that Kubernetes is an open source platform for managing containerized workloads. Great. But what about, say, Docker? Isn't Docker a platform for managing containerized workloads? Well, the thing about Docker is you install Docker on a host and you run your containers there. But that host is a single point of failure. Kubernetes gives us the option of having a fleet of hosts where we can run our applications. And if one of those hosts goes down, Kubernetes will automatically migrate our applications onto one of the other nodes. It gives us that inbuilt high availability for our containers. So when we're talking about why Kubernetes, what is Kubernetes? Basically, Kubernetes allows us to take container technology in the form of Docker containers and run them in a production environment, giving us that HA that we need for our applications. A little bit of history about it. Version 1.0 was released way back now in July 2015, originally developed by a company called Deis and then merged with Google. No, sorry, it was originally designed by Google and it merged with a company called Deis, who helped, no, I'm talking nonsense. Helm was developed by Deis. Kubernetes, we'll talk about Helm in a bit, I'm afraid, a little bit later. Kubernetes was originally designed by Google and then donated to the Cloud Native Computing Foundation, so that it's now completely open source. It's on GitHub. You can go and have a look at the source code there. Its code name, did anyone else just hear music? Its code name whilst it was being developed was actually 7 of 9 due to the spokes on the wheel there, but due to certain restrictions on naming, it was then changed to Kubernetes. You'll also see it abbreviated from Kubernetes to K8S, and the pure reason for that is there are 8 letters between the K and the S. But why do we want to use Kubernetes? Well, I've already said about the HA built-in features of Kubernetes, but why would we want to run, say, something like SQL Server in Kubernetes? Well, I talk about this a lot. Kubernetes is just another platform for us to run SQL Server. And like any other platform, it has certain benefits and limitations over other ways of running SQL Server. It's a really interesting time to be working with SQL Server. When back in the day, we only had, say, SQL Server on Windows. We now have SQL Server on Linux. We now have SQL in the cloud in the form of SQL DB, Amazon's RDS. We have Azure managed instances, and now we have SQL Server in Kubernetes as well. So we have all these different options to work with. Now, the main benefit of running SQL Server in a container is ease of deployment. We can easily spin up an instance of SQL Server and get it running in seconds. And we'll see this in the demos coming up. It'll take about 2 seconds for me to get SQL Server up and running in a Kubernetes cluster. We can easily upgrade, and we can easily roll back SQL Server as well. We're spinning up a new CU for our instances. We don't like it, we blow it away, we roll back to the previous CU, we are instantly rolled back. Gives us that confidence in testing new features. It's quick to spin up new containers, high availability built in, and I've got big data clusters on the slide there. I removed that just before this. I didn't refresh my slides. Big data clusters have gone now, but we still have things like Azure Arc, and Azure Arc is all built in Kubernetes. If you have a look at Azure Arc Data Services, in the background, you are running SQL Server in Kubernetes. If you want to get started with those technologies, learning the basics of Kubernetes is a really, really good thing to give you the fundamentals before playing with those technologies. So let's get started with running SQL Server in Kubernetes. And we've got a whole bunch of different options available to us here. So the best thing to do is get Kubernetes running locally on your laptop or in a lab, and we can use things like Minikube. We can use things like Micro K8s. We can use K3s, or you can even run it on one of my favorite, on Raspberry Pis, because we have an ARM version of SQL Server now that we can pull down and play around with. But the easiest method, especially if you're running on Windows, is Docker for desktop. You can install Docker, run Docker there, run your containers, and then if you want to run one node Kubernetes cluster locally, it's literally just a checkbox that you can tick. It will pull down all the containers that you need to run all the Kubernetes components, and within about 10 minutes, depending on your internet connection, of course, you can get a node of Kubernetes up and running that you can use to play around with and start deploying and testing. Other tools that we can use, well, you've got things like Visual Studio Code. Has great plugin for Kubernetes, and it has a great one. Red Hat have got a great YAML plugin as well. Actually, the YAML linter that will tell you different things about, as we'll see in the demos come up, what each component in your YAML file actually does, and if there's anything wrong with them as well. Then we have Azure Data Studio, and we have SQL Server Management Studio as well. So once we've got SQL Server up and running, we want to connect into SQL, and then we've just got an instance of SQL Server that we can use to build our databases, insert data, do all the normal stuff that we do with SQL Server. Then we have kubectl. You've heard it referred to probably as things like kubectl, kubectl. This is the main command line tool that we use for interacting with our Kubernetes cluster. I call it kubectl, kubectl. And then finally, command line tool to work with SQL Server. So we could use the new SQL command that's written in Go. That's really cool. If anyone hasn't played around with that, I highly recommend it. You can use it to actually spin up containers directly from SQL command. I actually like the MS SQL CLI. It's cross-platform, written in Python. The reason I like it is for when I'm demoing running SQL Server in Kubernetes, the output, the format of the output, which we'll see coming up, is really, really nice and clear. So without any further ado, let's actually jump in and let's start looking at SQL Server running in Kubernetes. So I've got Visual Studio Code running here, and I have Docker Desktop. There's my Docker Desktop running here. And you can see down here, I have Kubernetes running as well. And like I said, if we were to get this up and running, it is literally a checkbox. We literally click that, apply and restart. It'll pull down all the images that it needs to spin up all the containers for all the different components within Kubernetes. So let's have a look. I'm running locally, and I'm going to make sure I'm pointing at the right cluster. And I'm going to say kubectl, show me all my nodes. And there we go. I've got one node in this cluster, which is my laptop, status of ready, and I've got my version and how old it is as well. Version 1.28.2 is fairly recent. I think the most recent version is 1.29. Okay, let's not mess around. Let's actually go and run SQL Server in Kubernetes. So I'm going to say, if anyone here has run SQL Server in a container before, this should look fairly familiar. What we're saying is kubectl run and we're going to name this SQL Server from our image. And this one is going to be from the Microsoft Container Registry, the MCR. So mcr.microsoft.com, MS SQL Server 2022 CU5 Ubuntu 2004. The SQL Server 2022 CU5 image running on Ubuntu 2004. And then finally, we need to set a couple of environment variables. We need to do this every time we run SQL Server, not only in a container, but in Kubernetes as well. So we need to accept the end user license agreement, and we need to specify an SA password so that we can connect in. So 3, 2, 1, and execute. And I didn't clean up my delete when I was testing earlier. There we go. Okay. So let's just make sure there we go. Okay, delete service. There we go. Okay, let's try that again, shall we? Apologies. That was me not cleaning up my demos. 3, 2, 1, and run. And now I'll talk about what a pod is in a minute, but for now, let's have a look at what it is. And we've got SQL Server, 1 of 1, status of running, age of 6 seconds, up and running, looks good. So now what I can do is I can grab that pod name, and I can actually just jump into it. I can navigate to where SQL command is, and then I can connect to SQL and run something like select that version. And there we go. There is my version of SQL Server. SQL Server 2022 CU5 running on Ubuntu 20.04. Nice and simple. One pretty much kube control run, give it a name, specify the image, set the environment variables. Really easy to go. However, that's not really great to connect into SQL. We don't have to jump into the pod every single time we want to run a simple SQL command. We want to be able to connect from our desktops on our laptop into SQL running in Kubernetes. So if we jump out of here, and what I can do now is expose this service, and we'll talk about services in a bit more, but for now, I'm just going to run this one command. And if I have a look at this, I now get something called an external IP of localhost. And I can use that locally here to connect into my instance of SQL Server running in my Kubernetes cluster. And there we go, version Microsoft SQL Server 2022. So nice and simple with that one line of command to get it up and running, and then another command just to allow me to access it from within my cluster. I can now run the MS SQL CLI, or I can spin up Management Studio and connect in that way. Okay, so let's clean up something I didn't do earlier, apologies, and we'll jump back into the slides. So I was talking about a few things there. I was talking about control planes, pods, services. Let's have a look at some of these components in further detail. Now, the first thing are the types of nodes in Kubernetes. Now, thankfully, we only have 2 different types of nodes in Kubernetes. We have our control nodes and we have our worker nodes. Our control nodes hold all the components for, as you guessed, controlling the cluster. These are the management nodes, if you will, of the cluster. And they contain things like the Kube API server. This exposes the Kubernetes RESTful API and allows us to connect in with kube control and query the cluster to say what's running in the cluster. Can I deploy a pod? What's the status of all the nodes in the cluster? This is the main communication point that we go through when we want to talk to Kubernetes. Then we have etcd. etcd is a highly available distributed key value store that runs in the cluster, and its sole purpose is to maintain a persistent and consistent view of the cluster. What that means is whenever we create anything in Kubernetes, the Kube API server will talk to etcd and insert a record of it to say, hey, I've just spun this pod up, and make sure there's a record of that in etcd. Now, etcd is a database, which means we can do some cool things with this. We can back up etcd, and we can also restore it, which means we can roll the cluster back to a specific point in time. So say if you have a very large cluster, multiple control nodes, hundreds, if not thousands of worker nodes, thousands, tens of thousands of applications running, and something disastrous happens, it might be quicker to roll the whole cluster back with a restore of etcd than redeploying everything through your CI/CD pipelines. So it gives us that option there. Then we have the kube scheduler. The kube scheduler responds to requests and works out where to deploy applications within the cluster to ensure that no node in the cluster is overutilized or underutilized. It essentially acts as a load balancing mechanism for our applications in the cluster. Now, it will also respond to user requests. I can say things like label my nodes, so only certain applications run on certain nodes. And I could also taint nodes as well to ensure that applications don't run on those nodes. I can also put things like CPU and memory requests and limits in my deployments to say, guarantee that this deployment always has this amount of CPU and memory available to it on each of the nodes. And the kube scheduler takes all of that into consideration. Now, you do need to be a little bit careful when it comes to this, because if none of the nodes have the amount of resources that you're requesting in your, say, deployment YAML, the kube scheduler will kick back to you and say, look, I can't deploy anyway. You need to go and have a revisit of what you need. That's the scheduler. We then have the kube controller manager. Kubernetes uses a controller framework to maintain the state of the cluster. Kubernetes has this concept of desired state versus running state. For example, we define our desired state in a YAML file and then push it to the Kube API server, then deploys it into the cluster. At that point, it becomes our running state. And Kubernetes, through the controller manager, is always checking between the desired state and the running state. If anything happens to the running state and it no longer matches the desired state, Kubernetes will automatically fix that for us via the controllers. And there's a whole bunch of controllers. There's a node controller, namespace controller, deployment daemon set, stateful set controllers. And logically, they are all separate processes. But actually, in the cluster themselves, for ease of management, they are one single binary running. And the final one there is the cloud controller manager. This hooks into, say, if we're running in AKS, EKS, GKE, IBM's got a cloud managed service. There's a whole bunch of them out there. A Red Hat as well, tons of them. The sole purpose of the cloud controller manager is to hook into the underlying cloud's API to give Kubernetes access to the resources of that cloud provider. So, for example, if we spin up a service like we did in the last demo of a service with a type of load balancer. Now, in Docker, a Docker desktop, that just gives me an external IP of localhost. But doing it in a cloud will, say, AKS. The cloud controller manager will hook into Azure and say, hey, I need a load balancer for this service so I can get an external IP address. Please create me a load balancer. So that's the purpose of the cloud controller manager. So that's the control node, controlling our cluster. But we don't deploy our applications there. We actually deploy our applications to the other type of node in the cluster called worker nodes. And we have three main components running on these worker nodes. We have the kubelet, the kube proxy, and Docker. The kube proxy is responsible for maintaining networking rules on each of the nodes to allow us to communicate from outside of the cluster with our applications. And it works with either IP tables or IPVS. IP tables is the default. So what that does is when we deploy, again, that load balance service, it will go and fix all the networking rules on each one of the nodes, allowing me to hit the API server, hit the nodes, and then go into my applications. Then we have the kubelet. The kubelet runs as a service on each of the nodes, and it's responsible for taking a pod spec from the API server and ensuring all the pods in that pod spec are up, running, and in a healthy state. And it does this by talking to the container runtime. Now, by default, this used to be Docker, but now it can be any container runtime. That is what's called Container Runtime Initiative Compliant, CRI compliant. Is it initiative? Sorry, my head's gone for that one, but it's called the CRI. The reason for this, why Kubernetes brought this in, is to allow people to be able to swap out and use the container runtime that they want. They don't want to be limited to just Docker. But also Docker isn't CRI compliant. So they had to build something called the Docker shim to work between the kubelet and Docker. This incurred extra maintenance. They needed to maintain this Docker shim. But here's the thing. Docker isn't just a container runtime. Docker is a whole suite of products for managing containers. And buried within Docker is something called Containerd, which is actually the container runtime that Docker uses. And Containerd is CRI compliant. So why would they bother maintaining this Docker shim for Kubernetes to talk to Docker, where they could just directly talk to Containerd themselves? So that's why support for Docker was deprecated in Kubernetes version 1.20. I think actually removed, but double check me on this one, in version 1.24. So that's the reason why. They didn't want to maintain that network shim. They wanted to talk to the container runtime directly. So that's our worker nodes, where we run our pods. But that word pod, I keep saying that word pod. What does it mean? Well, pod in Kubernetes is the lowest logical unit that we work with. It's the smallest deployable unit of computing within Kubernetes itself. So we don't run containers directly, we run pods. And within those pods, there are containers run. Now you can have more than one container in a pod, but say for us running SQL Server, just one instance of SQL Server, typically it's just one pod, one container. But you can have multiples, things like say we have an application container and a logging container, application container, serving application traffic, and then writing metrics to logging container, which is then writing it down to say shared storage. So that's a pod where we run our containers, managed by our container runtime on our worker nodes, on a cluster that is maintained and managed by our control nodes. And the last bit I want to talk about is our services. Now, services are what we use to be able to connect to our applications within Kubernetes. Now, pods themselves, pods get an IP address that is only contactable from within the cluster itself. But say I have a deployment running one pod and that pod dies, Kubernetes will automatically fix that for us through one of the controllers, the deployment controller. The running state no longer matched the desired state, brought us up a new pod. But that pod will get a new IP address. So if we were connecting via the IP address of the old pod, we've lost our connection. Services provide a stable networking endpoint for us that we can use to contact our applications. And there are different types. We have cluster IP. We get an IP address that is only contactable from within the cluster. We have node port. A port is opened up on each of the nodes within the cluster, and we can use the node IP address and that port to connect to our application. Load balancer. If we're in the cloud, we get a load balancer spun up, and then we get an external IP provided by that load balancer, so we can contact our applications from outside of the cluster using that IP address. And then external name. We can map our service to, say, a DNS address, and then use that to connect in. Cool. So let's have a look at actually deploying SQL Server to Kubernetes. Now, there are different methods of doing this. We can use an imperative method, which we did before, where we said kube control run SQL Server from this image with these environment variables. But that's not typically the way we deploy applications to Kubernetes. We usually use a declarative method. We take everything we want, put it in a YAML file, and just push that YAML file into Kubernetes. And Kubernetes will work out what we want to deploy in that YAML file. So here we have, say, an example, a deployment, where we're going to say API version and a kind, which is a type of deployment. Metadata, we're going to give this deployment a name of SQL Server. Replicas, we're going to have one pod running one container of SQL Server here. And then we come down and specify the actual containers that we're going to run within our pod. And here we just have the one. We're going to call it SQL Server 1. From our image, and here I'm running to 2019 CU4 Ubuntu 16.04. Open up a port on our pod, port 1433, default port that SQL listens on. And there we are going to set our environment variables again. We've got our SA password and accepting the end user license agreement. Now, I 100%, before anyone says it, agree that having the SA password as clear text in a config file is not the best way of going about things. And we can do something about that. And we'll have a look at that in a bit with something called secrets. But for now, that is our deployment. We're going to deploy that. And then we need a way of contacting our application. We're going to define our service. So here again, API version, one type, kind of service. Metadata name, I'm really good at naming things. This is a service for SQL Server, so I'm going to call it SQL Server-service. And then we're going to open up our ports. So we're going to open up the port 1433 on our service and match to port 1433 on the pod that we're targeting. So if we hit this service on port 1433, it will route our connection through to our pod, and we will be able to connect to SQL Server. And then finally, we have our selector. This is going to be how we match our service to anything else running in the cluster. And this is going to go for the deployment SQL Server. And then finally, we have a type. And this one, we could be cluster IP, could be no port, external. But this time, we're going to go for load balancer. So let's go ahead and let's have a look at that in a demo. So if I close this one down and open up here, here we go. Well, let's have a look, make sure I'm connected still to the right. Yep. I'm in the, oh, I'm at the right cluster. Now, Kubernetes uses a concept called namespaces to logically group everything within the cluster. And all the control node components run in the kube system namespace. So here we've got DNS servers. We've got our etcd server. We've got our API server, our controller manager, our scheduler, and we have our proxy as well. So those are all the components that we talked about. The kube proxy is the one that works on it works on every single node, not just the worker nodes, but those are all the different control node components that we saw, because this is just a one node cluster. Okay, so let's set the location to my YAML, and let's have a look at that YAML file. Let's not do it there. Let's do it. Where is it? SQL Server. YAML. SQL Server. Here we go. So exactly the same as in the slides. I've got a deployment, and that plugin I was mentioning from Red Hat, really good linter, tells you exactly what's going here, number of desired pods. I didn't mention this, the selectors. Here we say for our deployment, we're going to match any pods that have the name of SQL Server. And then we come down to the template, we specify the label for our pods. Now it does look a bit redundant there because I'm doing them immediately one after the other, and there's only one label in each, but you can have multiple labels for everything to basically make working with these things a little bit easier. You can pull out the labels and select pods based on the labels and things like that. But for this one, to keep things simple in the demos, I'm literally just doing one label that this deployment's looking after, and then labeling my pods there. And we come down to our containers. If anyone's wondering why there's yellow wiggly lines there, we can hover over, and it's warning me that I have not set any resource limits for my pod. So I could technically have a noisy neighbor problem. I could deploy this. SQL Server will take as much memory and CPU as you'll let it have. And so this pod technically could take all the resources available on my laptop and starve any other pods I want to run. So that's why it's warning me here. But this is a demo, so don't particularly care. Let's have a look. Yep, name our container, our image, open up our ports, and then our environment variables. And finally, our service. Same as before, giving it a name, our ports, matching back to our selector. This is how this label here matches here. Nope, sorry, here. And then a type of load balancer. So let's go ahead and let's deploy. Let's get rid of that. There we go. So I'm in the right location, 3, 2, 1. So I'm just saying kube control apply. I'm not telling Kubernetes what I want it to do. I'm just saying take this YAML file and deploy those resources within it. So that's deployed. I can then have a look at events on the cluster. I can see here successfully assigned SQL Server to Docker Desktop, and that's coming from the scheduler, and it's scaled up, or something called a replica set, to 1 in my deployment. Now, these are events for the entirety of the cluster. So if there's a lot going on, actually using kube control get events isn't going to be great. So what we can do is we can jump in and have a look at our deployment. SQL Server 1 of 1. Yep, all good. We can view our pods. There we go. We've got the one pod running, SQL Server in it. If I want to get some more information, pretty much anything in Kubernetes, you can do -O and then wide, and that will show you a little bit more information. So here I get my name, data running, and the node that I'm running on, and my pod IP address there. If I want to get we had a look at kube control events. If I want to get the event specific to my pod, I can do describe pods. And this will give me a whole bunch of information about the pod states I can see. But again, not great, but still the environment variables are there. We can have a look. We can see the port that is opened, IP address, labels, name one of SQL, and when it was deployed. But further down here, we have a look here. We can see the events that have happened to this pod. So we can see the scheduler is kicked in. The scheduler said, hey, I've had a look at all the nodes in my one node cluster. I've decided to assign it to this one node. But if we had multiple nodes, this is where the scheduler comes in. It would use something called a bin packing algorithm to analyze resources available and current utilization of each of the nodes, and then chooses where to deploy our application. We can see the kubelet here saying, hey, the container image here is already present on the machine. If it wasn't, it would be talking to the container runtime to pull that image down from the MCR. A little tip when you're working with SQL Server and Kubernetes, pre-pull the image down to each one of your nodes. Now, the reason for that is by container standards, container image standards, SQL Server container images are gigantic. We're usually talking a few megs, few hundred megs for container images. The SQL Server images are about 1.5 gig. So if you run your application on a node in Kubernetes and something happens to that node, Kubernetes will automatically move everything to another node. But if that image isn't there, it will have to pull that image down. So you're talking extended downtime whilst that image gets pulled down before your containers can be started up. So always pre-pull your SQL Server images onto your Kubernetes nodes. Now, I say it's gigantic. You are talking to a man who once built a Windows SQL Server container image for 2014, which was 20 gig in size. So things are relative, but 1.5 gig for a Linux container image is pretty big. So always pre-pull them down. But then we see we've got the image already there. The Kubernetes said, hey, I've created the container, and now I've started the container. We can see the images and all the components kicking in our Kubernetes cluster. All righty, so we've got our pod up and running, and we also have our service. Now, because I'm running Docker Desktop, I don't have a load balancer going to be created for me. I just get an external IP of localhost. So I can use that to connect in to SQL via the MS SQL CLI. And there we go. Microsoft SQL Server 2022 CU5 on Ubuntu 20.04. So let's do some standard SQL Server stuff. Let's create a database. Do one. There we go. And we'll have a look. Is it there? Let's double check, do a select name from sys.databases, and there is our test database there. Okay. So let's clear that out. Let's have a look at this built-in high availability for Kubernetes. Let's see our pods. We've got kube control get pods output wide, and we've got it here. Says we're running 4 minutes, IP address 10.1.2.16. Let's grab that pod name and let's delete it. Okay. What's happened here now is that the running state no longer matches the desired state. So hopefully the deployment controller will kick in and automatically fix that for us. And there we go. We can see age of 19 seconds, but look, our IP address is different. The pod has got a new IP address. So if we were connected in from within our cluster to that IP address of the old pod and something happened to it, okay, we get that high availability, new pod is spun up, but we would have lost our connection. This is why services are important within Kubernetes. Okay, and then we can have a look at that service there. Yep, I've still got my local host, so I can select in. But hey, look at this. My database is gone. When we deleted the pod, Kubernetes spun up a new container for us, but spun that container up from the Microsoft image, which didn't know anything about any data changes that had happened since the initial pod was created. So our data changes are gone. Our database is gone. And when I mean gone, I mean gone. There is no way to get a deleted pod back in Kubernetes. So we need some method of ensuring that our data is persisted for us when we run SQL Server in Kubernetes. I've also mentioned that, I said this at the start, SQL Server, Kubernetes, SQL Server running in Kubernetes is just an instance of SQL Server. You still need to be taking your fulls, your diffs, your transaction log backups, like any other instance of SQL Server, just in case something does happen and you need to perform a recovery. There are a whole bunch of stuff out there that'll tell you, oh, you can use this technology, you can use that technology, you can do all these wonderful things. But the core of it, and I love running SQL Server because I do a lot of work with it, but you'll take my native SQL Server backups from my cold dead hands. You still need to be running those backups. Okay, so let's have a look at how to persist our data for SQL Server running in Kubernetes. Before we go into this, do we have any questions?
So far, I think we're good. If anybody has any questions, please drop them in the chat window here, and we will get them answered as soon as we see them.
Okay, great, no worries. Let's crack on. Let's talk about persisting our data. Now, that's because Kubernetes has the exact same issue with Docker containers. As we just saw, any data changes that are not on some sort of persistent volume in the cluster will be lost when a pod is recreated, because it's recreated from the image that is not aware of any data changes since the last pod was spun up. So we need to persist our data. Now, there are three main concepts for persisting our data in Kubernetes. The first one being persistent volumes. These are just a piece of storage in the cluster that's life cycle is independent of any pods accessing it. And what that means is one of the really cool things about containers and Kubernetes is it can separate out the compute from the storage. We don't really care about the compute if you think about it. When it comes to SQL Server, I mean, no SQL Server DBAs. We're used to looking after our SQL Server instances. We stroke them, we nurture them, we patch them, we whisper sweet nothings to them. We don't really care about them if you think about it. All we care about is the data underneath. A pod can come along, access the data on our persistent volumes, but when we're finished with it, we can blow it away, spin up a new one. We've got that separation of storage and compute here. So that's a persistent volume, just a piece of storage in our cluster. That's life cycles independent of the pods, and we can either statically create them, so we'd be creating disks, say, in Azure and attaching them to our cluster, or we can generate them dynamically. And we do that through something called storage classes and persistent volume claims. Persistent volume claims are just a request for storage by a user. So in my, say, deployment YAML, I put in a request for storage, and Kubernetes will go off and match my persistent volume claim, or PVC, to an actual persistent volume within the cluster. And we request size and access type. Now, the reason the pods reference persistent volume claims instead of going directly to the persistent volumes is that Kubernetes is infrastructure agnostic. We should be able to take our deployments or our stateful sets or anything we want to deploy into Kubernetes and deploy it in AKS, GKE, EKS, or an on-premises cluster without having to make any changes to that YAML. So that's why the persistent volume claims give us that abstraction over the actual persistent volumes in the cluster. So that's the reason for the two different types here. So the PVCs are referenced in our deployments, and then they map back to persistent volumes in our cluster. So if we want to create persistent volume claims, and we want to create our persistent volumes dynamically, we can use something called a storage class. Now, a storage class is just a type of storage available to us in our Kubernetes cluster. It is literally a class of storage. And here's an example one just of up and running in Azure. I've got a type of Azure Disk Provisioner, Kubernetes.io Azure Disk, standard level redundant storage, and a kind of managed. Now, because I have that storage class, I can then reference it in my persistent volume claim. So type metadata, MS SQL data, access mode. I'll come back to that. Storage class name. Now, there is a specific Azure disk there, but what I generally do is create something called MS SQL-storage. And then whenever cluster I run in, make sure that that storage class is available there to abstract, again, away that infrastructure. And then we have a request storage, and for a demo, I'm just going for 1 gig. I want to roll back and just talk about the access modes For storage in Kubernetes, we have three. Well, we used to have three. We now have four different types. We have read, write, many. Multiple nodes in the cluster can write to the storage. Probably not what we want for SQL Server. We have read-only many. Storage is read-only in the cluster, can be accessed by multiple nodes. Again, not great for us running SQL Server. The one there, read, write once, only one node within the cluster can access the storage. And that pretty much is pretty much what we want for SQL Server. However, that's one node running. Anything running on that one node can hit that storage. Typically, we only want one pod to be able to access our storage for SQL Server. So there is a new access mode now. I think it went beta in version 1.28, which is why I'm not using it here, because I'm running 1.28. It's called read, write once pod. Only one pod can access the storage. And I think that is going to be the standard going forward for running SQL Server in Kubernetes. But for now, because it's still in beta, I'm still using the old access mode, which is read, write once. Okay, now I mentioned that earlier on that having my SA password in clear text in a, say, deployment.yaml file, probably not the best idea in the world. So we want to remove that. And we can do that with something called secrets. So I can literally just create a secret here. And then instead of having the password in plain text in my YAML file, I can reference the secret instead in my YAML file. So it's just a nice way of not having sensitive information in my YAML file that I may deploy to, say, some GitHub repo and then pull it down when I need it. So that's a secret. We can use those. And then this is how we reference it. So instead of having it in clear text, we just say value from secret key ref, the name and the key within it, the SA password. So a little bit nicer, but there's a gotcha with secrets, and we'll see that in the demo coming up. But let's have a look at these persistent volume claims. Here we go. This is how we reference storage within our deployment.yaml. Now, one thing I will point out is I'm using deployment.yamls here for deploying SQL Server to Kubernetes. Now, deployments were generally used for and designed for stateless applications. There is another type of there's another type of controller even within SQL Server, within Kubernetes, and it's called stateful sets. Now, these are newer than deployments, and they are specifically designed for stateful applications, such as SQL Server. But generally, for testing, deployments, stateful sets, you can mix and match. You can use whichever one you'd like. When it comes to running in a production environment, 100% have a look at stateful sets. The Microsoft documentation will take you through. There are slight differences, but they generally follow the same format. API version, type, spec, define your containers. But anyway, here in our deployment YAML, we're talking about a volume mounts and a volume. So our volume mounts are where we are going to mount our persistent volume within our pod. And in our container there, we're going to say we're going to mount it at var opt ms SQL. And that's the location of, say, the system databases within a SQL Server running in a container. And then for further down, we reference our volumes, the name, and mapping back to our persistent volume claim. So, let's go ahead and let's have a look at persisting data for SQL Server in Kubernetes. All righty, here we go. Let's clear this out. Definitely on the right cluster, yes. Going towards my YAML. Here we go, got a storage class. I'm going to create a storage class that I can reference when I start building persistent volume claims. And because I'm working locally, my provisioner is going to be Docker and host path. And I'm going to give this a name of test storage class. Let's create that. Now, this is a bit redundant because I already have a default storage class, which is, there we go, host path here. But I just wanted to take you through the process of creating a storage class and then referencing it in a PVC or PV. So go ahead and that's the wrong button. Let's create a persistent volume claim. Pretty much exactly the same on the slide, name, MS SQL data, access mode, read, write once, got our storage class, and then our request for storage. Let's create that. And because I'm referencing a stat storage class, it's going to dynamically create a persistent volume for me. So I don't have to go, it'd be a really tedious operation if every time something deployed into Kubernetes, we'd have to go and create manually persistent volumes. It'd be a full-time job. But thankfully, I've got my PVC, and you can see that I've got a bound volume here. And that is my dynamically generated persistent volume. There we go. Of course, you need to be using a provisioner that supports dynamically creating PVCs, but pretty much any cloud provider will have that for you. And there are obviously companies with products out there for on-premise clusters that'll do this for you as well. If I do as described on the PV, we can see here where it actually lives on my host. And I can go and query that if I'd like to. And we've got a reclaim policy of delete. Now you need to be a little bit careful here. What that means is when I delete my PVC, it will also delete my persistent volume. Typically what you could do here is change that to something like retain, so that when I delete my PVC, I've still got my persistent volume, so I wouldn't lose any data. I'd have to manually go and delete it, just putting that extra step in there. Okay, so let's go and create my secret. Let's create a secret for my SA password. So kubectl create secret. There we go. And there it is, as a type of opaque. If I try and describe it out, try and get more information about it, I can't get access. You can see that I've got a load of gibberish there instead of where my SA password should be. Now, a word of warning with secrets. Secrets in Kubernetes are encoded. They are not encrypted. So what we can do is things like this and get at that password. Now, it's even easier if you're on Linux or a Mac. You just base64 decode it, base64-D, pass in the bit, and it will clean that for you. But you can do it on Windows as well, nice and simple, like that. Just to be aware that secrets within Kubernetes, although really good to not have everything in clear text, they're not as secure as you'd think. They're encoded, not encrypted. Just be aware of that. Okay, so let's create my persistent volume, same as on the slide. Oh, hang on. So let's have a look at my SQL Server persistent volume. We've got our PVC, we've got our PV. So same as before, replica of one, matching our labels, image, ports, environment variables now referencing our secret, and then our volume map. So we're going to have var opt MS SQL data referencing our claim, and then we've got our service here, same as before. It'll give me local host that I can use to connect in. So let's deploy. 3, 2, 1. Let's have a look. Everything up to date and available. Let's have a look at that pod. Yep, pod is up and running. And we've got our service as well with our external IP of localhost. So let's connect in, make sure everything's up and running. Excellent stuff. Okay. So now this time, let's create a database, same as we did before. And let's have a look at it. Excellent stuff. And let's have a look where those files are based. So we do xesp help file, and we've got our file names under MS SQL, var opt MS SQL data, where we've slid that persistent volume under. So now, if we have a look, let's do what we did before. Get our pod, grab the name, and delete it. So again here, the running state no longer matching the desired state. Kubernetes will automatically fix it for us. New pod, new IP address, but we've still got our persistent volume claim with our volume. So now, and our service as well, of course. So now, if I do a select name from sys databases, there is my database. So by using persistent volumes, we get the HA, high availability, for SQL Server in Kubernetes using that controller mechanism, running state versus desired state, and we're retaining our data as well. Okay. Let's do a bit of a cleanup here. There we go. And we'll jump back into the slides. Last 10 minutes. So what I want to talk about now is Helm, the product that was actually created by Deus, as I got confused earlier when I started the thing, when I was talking about Kubernetes history. You may have noticed that this is a lot of YAML. What was the YAML that we had for the last one? We had a YAML for storage class, persistent volume, claim, service, deployment. We could even YAML for the secret. It's a lot of YAML to manage. Wouldn't it be nice if we could bundle all of that YAML up and have one nice, easy to deploy package that we could just push into Kubernetes? And that is what Helm is. Helm is a package manager for Kubernetes. I like to think of it as apt-get or DNF or even winget for Windows now for Kubernetes. There is a SQL Server package available in what's called the Helm Hub. It's now called the Artifact Hub. It allows us to pull images down and deploy, and we can have things for our persistent volumes, persistent volume claims, secrets, services, all nice bundled up into one easy to manage package. The package on the Helm Hub, I think now has been deprecated, but you can build your own. And I would highly recommend whenever you're working with SQL Server in Kubernetes, yes, pulling down the image from the MCR is fine, and then running in a deployment, but I would very much recommend building your own deployments, building your own container image, and then using some sort of custom container registry to host those images in, and somewhere to host your Helm packages as well. But let's not mess around. Let's go and have a look at Helm straight away, because I'm conscious of time. Okie dokie. So let's close that. So Helm used to be a client and server components. It is now just a client-only component as of version 3. Version 2 was server client. The reason for that was the server component basically had free run of your cluster, and it was a security concern. So they decided to, it was called Killer, and they decided to nix it. So that's why Helm now is a client-only version, and it uses the same config file as your kube control to point at the cluster. So you can control where your Helm's pointed at via kube control. So if I go into here and have a look, what I've got in my little package here, Helm, I have in my templates, just a volume claim, secret, service, SQL Server, and a storage class. All of this stuff all bundled up into one easy to manage package. I can do a test run as well. I can do dry run debug, and it will tell me exactly what it's going to deploy to my Kubernetes cluster. It'll work out everything in order as well. So it'll give me my secret first, my storage class, my persistent volume claim, my service, and then my deployment. Whole bunch of stuff here. Nice and simple. And I've got some notes at the end there on how to deploy. So 3, 2, 1, let's deploy. Excellent stuff. And if I have a look there, Helm list, there we go, SQL Server in my default namespace, revision 1, status of deployed. Get my deployments. List my storage. There we go, storage class, persistent volume, and my persistent volume claims. All there, all created for me from that one package. And I've got my pod there as well, my secret, and my service. A lot easier than having to manage all those different YAML files. Push them all into one package, do a dry run, make sure everything's okay. You can check everything that's going to deploy, and then deploy in. And then let's see if everything's working. Let's just connect into SQL Server. Excellent stuff. SQL Server 2022 CU5, as we've been deploying throughout all of these demos. So if you're going to work with SQL Server and Kubernetes, highly recommend you check out Helm. And then if I want to delete, Helm delete SQL Server, and we get rid of it. Okay, right, last section. Let's jump back into the slides for the last part. So when I was doing a proof of concept for SQL Server and Kubernetes at a company I was working in, we were testing this high availability, deleting, shutting down nodes, and watching Kubernetes move the pods from one node to another, respinning up pods to make sure the desired state matched the running state. And I was demoing it out, but it was all very, as you've seen, like very codey, very all on the command line. And my boss at the time was like, okay, Andrew, this is great, but could you jazz it up a little bit? And I was just sort of a bit confused by this. So I was like, what do you mean, like jazz it up? Like jazz hands? I was like, no, 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 no. Could you say find like a graphical user interface to demonstrate this? Could you, clean it up a little bit so it's not quite so codey? And I was like, okay, you need a GUI. All right. So I went and started looking around to test HA, high availability for SQL Server using chaos engineering tools, resiliency testing tools. And I found probably my favorite project in GitHub. And that project is Kube Invaders. This is a chaos engineering tool to test application high availability in Kubernetes using Space Invaders. And it does exactly what it says on the tin. We play the spaceship and they play the pods are there, the invaders there are our applications, are our pods, and we can play the game. So I'm not going to mess around. Let's have a look. So what I'm going to do here is I'm going to connect to, now this is running up in a cluster in Azure. So I'm going to connect into that cluster. Confirm. There we go. And I'm going to set my, and make sure here. And I'm going to deploy SQL Server via a YAML file. Here we go. Where is it? Kube Invaders. But this time it's exactly the same as we've done in the previous demo. But this time I'm going to have 10 replicas. I want 10 instances of SQL Server here. And not typically what you do, but for this purpose, let's do it. 3, 2, 1. Let's have a look. And then we go. I have 10 instances of SQL Server. By the way, how fast was that? Let's go ahead and let's have a look at what we can do. So if I come over here, watch those pods, and now I can play the game. 1, 3, and we can see they're coming back pretty much instantly. But we can see on the other side, the desired state's no longer matching the running state's not matching the desired state, and Kubernetes is fixing that for us, getting 10 back. Now, eventually, if I keep doing this, it will end up dying, because after a while, the controller won't be able to keep up with me constantly killing pods and having to redeploy, constantly killing pods and redeploy. And these little things here are the server nodes. And what I can do here is actually run stress tests on each of the nodes. And you can see here that has absolutely caused mayhem in my cluster. This is a really good way of testing how good your HA, how good the Kubernetes high availability capabilities are for your applications running in any Kubernetes cluster. So if you are looking at testing stuff like that, I highly recommend you have a look at Kube Invaders. It is pretty much my favorite GitHub project that I've ever seen. And I'll have a link to that at the end. Let's jump back into the final slide here. So this is the link to my GitHub repo for this, where all the slides and the code that for all the demos that we'll be doing. There'll be links to all of the bunch of different resources as well, including the Kube Invaders project. Thank you so much for having me. Are there any questions?
We do have one. I gotta say that Kube Invaders is probably the coolest thing I'm gonna see all month. That was amazing.
It's my favorite project. The joke I always say is this is actually how I demonstrated SQL Server high availability in Kubernetes to the C-level management of my company. It may or may not surprise you that I don't work for that company anymore.
See, that's people I want working with me. We do have a question here.
Yes.
So the container can take any size image, but you don't need any configuration around the container itself in YAML or anything else, right?
Well, you define the container. So things like resources requests, you can define. So resource requests and limits, you can define. You can define the environment variables all within that deployment YAML. Where are we? So if I say pick, if we go, let's go a little bit demos, and let's have a look at something here. So within the container here, well, that's not the best one. Let's have a look at this one. Here we go. So it gets the ones I was using here are very simple demos, but once we get into the spec here, the pod spec, you can do things like, okay, SQL runs as a non-root user within containers. So you need to specify that this to grant access to, say, persistent volumes. You can do things like tolerations for your containers. So if a node goes down, the default will be 5 minutes. And so Kubernetes will move your pods off a down node after 5 minutes, and that's not good enough. So you want things like tolerations to say, move it quicker, and here's 10 seconds. But then we can get down, that's the pod. And then we drill down into the container itself. And then we have the name, the image, the port that I want to open up in the container, all my environment variables, and then things like resources requests. So minimum of 1 gig of memory, 1 CPU. It's in cycles, but it's pretty much 1 CPU. Memory 2 gig, 2 CPUs, and then things like liveness probes. We can have Kubernetes constantly check to see, it's like a looks alive check to say, oh, is this container responding on port 1433? If it isn't, it will then kill the pod and spin up a new one for us. So yes, you would define a load of container stuff within your YAML file there, and there can be quite a lot of stuff in there.
Cool. We have a good long question here. So reading this off natively here, would a use case for this be to allow people to query a database independently from different containers without impacting a production system? Like, could analysts take a copy of a database and run it in a container or against storage? Trying to figure out kind of the raw usage of this. And I could answer this, but I'm going to let you do it.
Yeah, it's 100% you can do this. You can take a clone of database files and present it into a Kubernetes cluster and then spin up a container referencing that data there. It'd be a really easy way of getting lots of instances of SQL Server running to test anything really that you could think of. You could spin it up to do performance testing. You could do investigations to see of data analysis, things like that. This is a very good use case for getting multiple copies of a database up based on some sort of cloning technology there as well. Yes, so if you could clone your existing production volumes and push them, say, into somewhere that wherever your Kubernetes cluster is running, and then spin up a load of containers and have them running in, and then have them referencing those clones. Yes, 100% you could do that. That's a really good use case for it. Another really good use case for Kubernetes and SQL Server is, who here has ever installed an application and it needs an instance of SQL Express running? And you end up with all these little instances of SQL Express dotted around your environment that one of them always goes missing and gets forgotten about. I've found in my experience. What you could do instead is install it into Kubernetes and have them all running in there. You have them in one place that you know where they are. You get that built-in HA there. And typically these are like corporate tools as well. So say you forgot your tolerations and it was down for 5 minutes, it doesn't really matter because it's a corporate tool, but you have that built-in HA there that you can tweak. It's a very good use case for SQL Server, getting rid of those SQL Express instances that are the bane of DBA's lives.
So I have a question for you.
Yes.
I see a lot of these in pre-production environments in the field, and just like you just mentioned, small deployments like replacements for SQL Express, stuff like that. In terms of, let's say, moderate to actually pretty big size deployments, how much of this are you actually seeing in production?
I'm starting to see more and more of it.
Cool.
We've got a few customers who are running SQL Server in Kubernetes now, and I will say that when I first started talking about SQL Server in containers, I was at Bits and people looked at me like I was mad. And then last time I went to Bits, there was sessions about SQL Server in containers everywhere. It's taken a little bit of while for adoption to start kicking in, but I'm starting to see more and more of it now. I think it scares people because there's a whole stack there that seems really complicated, but when it comes, it is quite simple. It's just that there's so much information out there, and we were saying before, like if you go to the Kubernetes documentation and look at what a pod is, it'll tell you in depth, but the entry point can be quite difficult. But no, we're starting to see more uptick of it now, especially around. Disclaimer, I work for a storage company that does a lot of snapshot technology. So around that technology, people snapping and pushing into the cloud and then spinning up instances in Kubernetes to reference and test, DR purposes as well, things like that. Yeah, so the uptick, it's starting to get more and more momentum.
That's cool. I feel your pain. When I started talking about SQL Server and virtual machines in 2005, 2006, people told me I was clinically, medically ill. And then 2010, it started to become mainstream. About 2012, 2013, people started really rolling with it. So I'm watching the cycles repeat, and it's virtualization, then cloud, now containers, and they'll get there.
Yes, 100% agree with you on that. I think things started clicking with people when I started talking about stuff like, do you remember those days where in order to test a new version of SQL Server, we had to spin up a VM, pull down the CTP, install that, and then do our testing? Those days are gone.
Yeah.
If we just pull the new image down, spin it up, test it, blow it away once we're done with it, and we do it in seconds. And then people are like, this is great. And then what else can I use it for? And you're like, aha, here we go. I've got you hooked in.
So now what's hilarious is now I'm just waiting for the next big thing after containers. And I figure it's going to be contained databases squared, where the SQL Server engine is embedded in the database. Now I don't know, I'm just shooting in the dark. It's like what's coming next? And then when the next thing is out, then the masses will be on the current wave of technology innovation.
Yes.
It's fun. It's so cool to see this stuff evolve. When containers first came out, there are a lot of limitations, Active Directory authentication, shared storage availability, things like that. But it's certainly getting there. It's so much fun to watch.
Oh, they're such an amazing technology. I'm kind of glad that Microsoft didn't keep pushing Windows containers for SQL Server. They went with the more mature technology, which is the SQL Server on, Linux containers, because Linux containers have been around for so long. As you see, like the image is a lot smaller, it's a lot faster to spin up. Yeah, I'm glad they went that way and then doubled down on it with getting rid of the Windows images. So if you want to run SQL Server in a container, it has to be on Linux.
Me too. I was actually compiling Slackware Linux kernels when I was 14 in 1993. That's how long of a background I have with Linux on this stuff. So
I have a question.
yeah, go for
Of
it.
course.
So nowadays we have a cloud environment where we deploy everything, right? So EKS, Kubernetes, HEM. So I'm always confused. Like normally in industries, what nowadays being used? Either managed services like EKS, yeah, or either we go via raw declarative deployment, or either HEM. So what is good to learn nowadays?
Everything.
So I would very much recommend when you first get in working with Kubernetes, and even if you're an experienced Kubernetes operator, if you have the ability to deploy in a managed Kubernetes service, I would use the managed Kubernetes service. It will take a lot of pain away, especially around the management of the control plane. If you're running on premises, you need to have HA for your control plane. It means multiple control planes. It means provisioning some sort of load balancer over the top of your control planes to make sure you're not hitting an individual node. You need to look at whether or not you're going to have how are you going to do HA for etcd? Are you going to have etcd running on the same nodes as your control plane nodes, or are you going to move it out into its own cluster? Are you going to back it up? Are you going to look at restoring it at any point? If you are going to look at that, you need to test it, because it evolves quite quickly, and it makes the documentation out of date very quickly. So you need to be running. So if you are looking at working with Kubernetes and you have the ability to deploy in a managed service, I would 100% start there, definitely.
Yeah, I've been working here in my test lab with a lot of Proxmox with some automation for a container platform. Scale out HA, it's just ready to go.
Scale out, yes.
Yeah, you just start using it. You don't have to worry about managing it as well. There's as much.
If you want to get into the real internals, if you really want some fun, I built a Kubernetes cluster out of 3 Raspberry Pis, and that will really teach you if you really want to learn the internals, that'll teach you.
That's cool.
And it is worth to learn the Docker shim and all also. Only Kubernetes are good.
They could be run. I learn them in tandem. Docker containers are great for CI/CD pipelines, local testing, but when you move into a production environment, then you need that HA, the orchestration that Kubernetes provides. So definitely learn them hand in hand. I mean, you don't have Docker on Kubernetes anymore by default. I think Azure is now using Container D, but Container D has you never go and actually play around with Docker in Kubernetes. You let Kubernetes manage everything for you. So Docker for local testing and development, maybe CI/CD pipelines, and then Kubernetes for your production environments.
Okay.
Thank you.
Bottom line, it's all about the continuous learning. That's the only constant that we have in IT careers, is that the only constant is change. We have to continuously keep up. And the problem with it is, for every one new thing you learn, you now discover 2 more things you need to learn.
Yes.
And call me odd, I thrive on that kind of stuff, but it is a constant challenge to keep up.
I go down rabbit holes like Helm, Kubernetes and Helm are all written in Go. And one of the really cool things about Helm is it has the ability to roll back further than Kubernetes does, because it stores all your deployments in secrets in Kubernetes. We saw it actually right at the end there when I was looking at this. So say you delete everything, you can still get your stuff back because it's all stored in that Helm secret. So I went down one evening and was like, okay, let's have a look at exactly how this secret works, because it's as I said, they're encoded, not encrypted. So I ended up on the Helm repo in GitHub, crawling through the Go code to work out how to decode all of these Helm secrets, just because I'm interested in how, I want to know how this works. So
I love that innate curiosity.
100%.
Yeah, I'm actually going to be building my own SAN because I want to learn more about how it does deduplication and compression.
Oh, nice.
Yeah, I'm lucky I have a very, very understanding spouse.
And any good UI tool you suggest for monitoring the Kubernetes cluster?
There is a good command line tool called K9S.
UI?
That's really K9S.
Okay.
It is command line, but it's graphical when you go into it. And it's really good. And then there are other options out there as well, which I cannot remember off the top of my head. But there's a really nice one. No, it's gone, I'm afraid. It's just not in there at the moment. But there are ones out now. Kubernetes does have a built-in dashboard itself, but it's not very good. So I really wouldn't look at deploying that. But there are ones out there. But the one I've seen most used is K9S.
Okay.
Awesome. Are there any other questions from anybody that's still on? All right. Well, hey, thank you for presenting. That was absolutely awesome. I have got to get more time to play over here.
No, thank you very much for having me. Really enjoyed.
You're welcome. Thank you, everybody, for watching. And if you're
Thank
watching
you so
this,
much. Thank you.
thank you. Thank you for attending.
Thanks a lot. Appreciate it.
And if anybody is out watching this on YouTube after the fact, he's got his contact info in the slides at the beginning there. Do not hesitate to reach out to Andrew or any of us at the HEDR virtual group. 1, we're happy to answer your questions. 2, if you have an idea for a future presentation, let us know. Quite literally, about half of our presentations come from people asking really good questions, and I find a presenter, or honestly, we would, twist somebody's arm and actually get them to write a presentation for us. So this is for you all. So thank you all very, very much.